Bismillahirrahmanirrahim and Assalamu alaikum to you all. On behalf of DHU Education System, I welcome you all in my computer class. Course code is 2210. In week 3 for class C1, format of this session will be carried out by taking review of the topics covered in week 2, that is hexadecimal to binary conversion, binary to hexadecimal conversion, hexadecimal to denary conversion, and denary to hexadecimal conversion. Then the topics to be covered in week 3 and their learning objectives will be discussed. Content of the topics will be explained through diagrammatical representation. Quick recap will be taken, and in the end, assignment will be given that you can download from the DHU portal. In week 2, when we were converting a given binary number into the equivalent hexadecimal number or a hexadecimal number into the equivalent binary number, we used table 1.2. Now let's take a quick glance on the example 2 to convert a given binary number into the equivalent hexadecimal number. From the example, we will first split this group into 4 groups of bits. So the left group only contains 2 bits, so add in 2 zeros in the start to make it complete group of 4 bits. Now use table 1.2 to find the equivalent hexadecimal digit. In this way, we just need to look at the first group, which is 0010, and its equivalent hexadecimal value is 2. In the next group, the value is 0001 and its equivalent hexadecimal value is 1. Third group contains 4 digits 1111 and its equivalent hexadecimal value in the table is F. And the last group contains 1101, and if you just look at the equivalent hexadecimal value, which is D. So the answer is 21FD. Now in example 3, we are given a hexadecimal number and we are asked to convert it into the equivalent binary number. So again, we will use table 1.2, find the 4-bit code for each digit. So the first hexadecimal digit is 4. We need to see what is the equivalent binary value against it. So that is 0100. Then the next digit is 5 and its binary value in table is 0101. And then the next digit is A and its binary value in the table is 1010. Put the groups together to form the binary number. That is the answer. Then to convert a given hexadecimal number to equivalent denary number, we used hexadecimal notation method. So in example 1, the question is 45A. We will first multiply each digit with its value, that is its hexadecimal notation value. We will add the totals together to get the equivalent denary number. Now, if you are given a denary number and you are asked to convert it into the equivalent hexadecimal number, for example, you are given a number 2004 and you have to convert it into the hexadecimal number, you will be using the remainder method. You will divide the number with 16 and keep it dividing till you get quotient lesser than the divisor. So in this way, we got the number 7D4. We will read the remainder from bottom to top to get the hexadecimal number. After that, we discussed character set. Text and numbers can be encoded in computer as pattern of binary digits. So that can be anything, text, number, or any special character. We discussed coding schemes, ASCII, extended ASCII, and Unicode. The ASCII character set is a 7-bit set of codes that allows 128 different characters. Extended ASCII code is an 8-bit character set that represents 256 different characters, while Unicode uses between 8 and 32 bits per character, so it can represent any characters from languages from all around the world. That was the review of the topics that we covered in week 2. To learn the methods of interconversion of number systems, this diagram may help. If you are given a January or a decimal number and you are asked to convert it into the binary number or into the equivalent hexadecimal number, then you will be using the remainder method. If you are given with a binary number system or if you are given with a hexadecimal number system and you are asked to convert it into the equivalent denary or decimal number system, then you will be using the expansion method. So if you are given a binary number, you will be using the binary notation method, or if you are given a hexadecimal number, you will be using a hexadecimal notation method. And in last, if you are given a hexadecimal number and you are asked to convert it into the binary number system, you will be using 4-bit BCD table notation or table 1.2 that is given in your book. And similarly, if you are given a binary number and you're asked to convert it into the equivalent hexadecimal number system, you will be using the same 4-bit BCD table notation. That was end of the chapter number 1. Now we will start the new topic of week 3, that is chapter number 2. In week 3, we will cover topics from chapter number 2, that is communication and internet technologies. We will cover the topics data transmission, simplex, half duplex and full duplex, serial and parallel data transmission, asynchronous and synchronous data transmission, and in the end, universal serial bus or USB. By the end of this lesson, students, you should be able to describe term transmission of data, distinguish between simplex, half duplex and full duplex data transmission, differentiate between serial and parallel data transmission, explain asynchronous and synchronous data transmission, show understanding of the reason for choosing serial or parallel data transmission, identify current uses of serial and parallel data transmission such as in USB or universal serial bus. Let's start our topic with the term data transmission. Data transmission can be either over a short distance, for example, from computer to printer, or over longer distances, for example, over a telephone network. So, a person who is sending the data is known as sender or source, and at the receiving end, the person who is receiving the data is known as receiver or destination. Data is transmitted in the form of zeros and ones. The zeros and ones are encoded in the form of signals processed and decoded to read at the receiver's end. Data is also processed in the form of signals on and off, which are the analog signals. Essentially, 3 factors need to be considered when transmitting data. Each factor has to be agreed by both sender and receiver for this to work without error. Number 1, the direction of data transmission. That is, in one direction only or in both directions. Number 2, the method of transmission. How many bits are sent at the same time? Either it's 1 bit or 8 bits or 16 bits or 24 bits or 32 bits or even more. Number 3, the method of synchronization between the 2 devices. So these 3 factors are the important factors when the data is being sent between a sender and the receiver. So it's kind of agreement. There are three modes of transmission. These modes are important when it comes to the direction of data. They are known as simplex data transmission, half duplex data transmission, and full duplex data transmission. In simplex data transmission, one direction only is allowed, for example, from sender to receiver. So data from the sender can be sent only, and receiver can only receive whatsoever is sent from the sender. Example, data being sent from a computer to a printer. In this case, printer cannot give any sort of feedback to the computer. So this is totally one direction or unidirection of data transmission. In half duplex data transmission, transmission helps in both direction but not at the same time. That is, data can be sent from A to B or from B to A along the same line but not at the same time. So this sort of direction or transmission is known as the half duplex. You can also see that in the diagram that data is being transmitted from one workstation or from one computer to the other workstation or to the other computer. So transmission and the direction of data is at a time at one side. Example, a phone conversation between two people where only one person speaks at a time. Rather, there is a better example of wireless communication or using the walkie-talkies. When one person is done with a message, the other person can only respond to that. In the third mode of data transmission, that is the full duplex data transmission, transmission is in both directions simultaneously. That is, data can be sent from source A to destination B and from destination B to source A along the same line, both at the same time. So this is bidirectional transmission of data here. An example is broadband connection on a phone line, or you can say the video conferencing, or you can say the mobile communication, or the usual telephonic communication is the example of full duplex data transmission. So these were the three modes of communication: simplex, half duplex, and full duplex. Types of data transmission. Categorically, there are two types of data transmission: serial data transmission and parallel data transmission. Serial data transmission. Serial data transmission is when data is sent one bit at a time over a single wire or channel. Bits are sent one after the other in a single stream. So there is a sender and there is a receiver, and they both can send data and receive data from each other. You need to note here that bits can be transmitted as simplex, half duplex, or full duplex. It means that the transmission can help whether in one direction or in partially two direction or bidirection or in fully bidirectional. So, for example, if a user or a sender sends a data, for example, if it is some character D, so D is equivalent to some binary value. So that binary value will be sent or will be transmitted towards a receiver bit by bit through the wire or through the data bus. So for example, if it is the binary value 10110100, so each bit will be sent one by one in the serial transmission or serial communication. This method of data transmission works well over long distances. However, data is transmitted at a slower rate than parallel data transmission. Since only one wire or channel is used, there is no problem of data arriving at its destination out of synchronization. An example of its use is sending data from a computer to a modem for transmission over a telephone line. So here you can see a sender is sending the data towards a receiver, and data is transmitted in the form of bytes. So each byte is sent through the same wire and its bits are transmitted one by one, and then the next byte is sent, and then the next byte is sent, and this is how the serial data transmission will held. We will see what is asynchronous or synchronous transmission later in this lesson. Parallel data transmission. Parallel data transmission is when several bits of data, usually 1 byte, which means 8 bits, are sent down several wires or channels at the same time. One wire or channel is used to transmit each bit. Here you also need to note that data can be transmitted as simplex, as half duplex, or as full duplex. So 8 bits or even more than those can be sent in one direction or in both directions. So you can see in the second diagram that the sender is there. Sender is sending a letter, for example, it is letter D, and its binary code is transmitted. So we know that one character is holding the data in 1 byte. So here 8 parallel lines are there, and through these 8 parallel lines, each bit is transmitted towards the receiver. So this is how parallel communication or parallel data transmission held. This method of data transmission works very well over short distances. Over longer distances, the bits can become skewed or mingled up. This means they will no longer be synchronized. It is, however, a faster method of data transmission than serial. An example of its use is when sending data to a printer from a computer using a ribbon connector. So in ribbon connector, there are 8, 16, 24, 32 parallel holes are there, which send 8, 16 or 24 or 32 bits of data in parallel. So in the diagram, you can see 1 byte data block, which means 8 bits are sent all together from 8 different lines. Parallel data transmission is used in the internal electronics of the computer system. The pathways between the CPU and the memory all use this method of data transmission. Integrated circuit, IC chips, buses, and other internal components all use parallel data transmission because of the need for high-speed data transfer. The use of 8-bit, 16-bit, 32-bit, and 64-bit buses, for example, allow much faster data transmission rates than could be achieved with single-channel serial data transfer. An internal clock is used to ensure the correct timing of data transfer. It is essentially synchronous in nature, and the short distances between components mean that none of the issues described earlier have any real impact on the accuracy of data. Asynchronous and synchronous data transmission. Asynchronous data transmission refers to the data being transmitted in an agreed bit pattern. Data bits, ones and zeros, are grouped together and sent with control bits. In the first diagram, you can see data is started and ended with a control bit. So the starting bit is known as the start bit and the ending control bit is known as the stop bit. This means that the receiver of the data knows when the data starts and when the data ends. This prevents data becoming mixed up. Without these control bits, it would be impossible to separate groups of data as they arrive. You can see in the second block diagram the direction of flow, a byte of data, the start bit, which is shown in yellow color, the stop bit, which is shown in brown color. So here, the sender and the receiver and the transmission of data is being done in the form of bytes. So there is a gap between data unit just to distinguish that multiple data bytes are transmitted with the help of start and stop control bits. Synchronous data transmission. Synchronous data transmission is a continuous stream of data, unlike asynchronous data, which is sent in discrete groups. The data is accompanied by the timing signals generated by the internal clock. This ensures that the sender and the receiver are synchronized with each other. The receiver counts how many bits that are ones and zeros were sent and then reassembles them into bytes of data. The timing must be very accurate here since there are no control bits sent in this type of data transmission. However, it is a faster data transmission method than asynchronous and is therefore used where this is an important issue, for example, in network communication. You can see that block diagram of synchronous data transmission, the direction of flow of data from sender to receiver, and that's a continuous stream of bits. But one thing that makes difference is the timing that are synced between sender and receiver. USB or Universal Serial Bus. The Universal Serial Bus or USB is an asynchronous serial data transmission method. It has quickly become the standard method for transferring data between a computer and a number of devices. Essentially, the USB cables consist of a 4-wire shielded cable. 2 of the wires are used for power and the earth. 2 of the wires are used in the data transmission. You can see in the diagram a typical USB cable. When a device is plugged into a computer using one of the USB ports, the computer automatically detects that a device is present. This is due to a small change in the voltage level on the data signal wires in the cable. The device is automatically recognized and the appropriate device driver is loaded up, so that computer and device can communicate effectively if a new device is detected. The computer will look for the device driver which matches the device. If this is not available, the user is prompted to download the appropriate software. Even though the USB systems has become the industrial standard, there are still a number of benefits and drawbacks of using this system. Here a table 2.1 is given in your book, and the first column shows the benefit of using USB, and there are few drawbacks that is given in the next column. The first benefit is devices plugged into the computer are automatically detected, device drivers are automatically uploaded. The second benefit is the connectors can only fit one way. This prevents incorrect connections being made. Third benefit is this has become the industrial standard. This means that considerable support is available to users. Fourth benefit is several different data transmission rates are supported. And fifth benefit is newer USB standards are backward compatible with older USB standards. This means that older USB ports can be used to run or to detect the newer USB devices. There are few drawbacks of using USB. The first one is maximum cable length is presently about 5 meter, not more than that. So the length of the cable is very short. Number two, the present transmission rate is limited to less than 500 megabits per second, but it is also increasing with the passage of time. The older standard USB, for example, that is version 1.1, may not be supported in near future, although right now it is compatible with the older or the backward USB standards, but it is predicted that in future these will not be compatible with the newer version. That is it for the lesson. Now let's take a quick recap. The topics we covered today. Data transmission. Data transmission refers to the communication between two devices from sender to receiver. So the data transmission refers to sending data from one source to the other destination. Then we discussed the three modes of communication that particularly emphasize on the direction of the data to be transmitted. In simplex data transmission, data is sent from source to destination in one direction only. In half-duplex data transmission, data is transmitted from source to destination in both directions but in one direction at a time. While in full duplex data transmission, data is transmitted from source to destination in both directions simultaneously. Then we discussed the differences between serial and parallel data transmission. In serial data transmission, data is sent over a single wire and data is sent bit by bit. In parallel data transmission, data is sent from source to destination through 8 parallel wires or 16 parallel wires or 32 parallel wires, all bits all together. Serial data transmission is best used over the longer distance, while parallel data transmission is used over the shorter distance. Then we discussed about asynchronous and synchronous data transmission. In asynchronous data transmission, the bits are sent over the wire with the control bits. So in the start and end of the byte, the control bits are added. While in synchronous data transmission, there are no control bits added, yet a continuous stream of bits are sent, but the timings are synchronized between the sender and the receiver. And last, we discussed about the USB and USB cable and the benefits and drawback of using USB. Now you can download the practice questions from the DHA portal to practice and solve. Thank you so much for listening carefully.